Good afternoon, everybody. Welcome to Weaponizing Data Science for Social Engineering, Automated E2E Spear Phishing on Twitter. We are in the South Seas ABE room with John Seymour and Philip Tully. Now, before we begin, a few brief notes. The Black Hat Arsenal is on the Palm Foyer on level 3, and of course, the Arsenal reception is at 5. Stop by the Business Hall located in Bayside AB. If you haven't picked up your merchandise, today is your last chance to visit Black Hat Swag and Bookstore, and visit the Kali Linux Lab in Mandalay Bay A. Thanks for putting your phone on vibrate. It makes it easier for the rest of us to ignore the ringing while you wait for your voicemail to pick up. And here we go.
All right. Thanks for that introduction. Every year, Black Hat asks its attendees what are their greatest concerns. And every year, phishing, social network exploits, or other forms of social engineering is near the top of the list. Traditionally, there are two types of phishing campaigns: standard phishing, which is usually automated but has a very low success rate, and spear phishing, which has a much higher success rate but with much higher cost. The social media pen testing tool we demonstrate and release today combines the automation of phishing with the effectiveness of spear phishing. And with that, we'd like to thank you for coming to our talk called Weaponizing Data Science for Social Engineering, Automated End-to-End Spear Phishing on Twitter. My name is John Seymour. My hacker handle is Delta0, and I'm a data scientist at ZeroFox. During the night, I'm a PhD student at University of Maryland, Baltimore County, and in my free time, I like to research malware data sets.
Okay, and my name is Philip Tully. I'm a senior data scientist at ZeroFox. So ZeroFox is the social media security company. It detects, prevents, and takes down threats emanating from social media. In a past life, I did a PhD at the University of Edinburgh and the Royal Institute of Technology in Stockholm, Sweden. And my research focus there was more on brain modeling and artificial neural networks. So I was trying to figure out how the brain stores and recalls memories in the form of patterns of spikes that were emanating from these individual neurons, very biologically detailed models. Now, I think this technique transitions well into the field of social media. Instead of finding patterns within spikes, I'm dealing more with finding patterns and generating text, right? So this is called natural language processing. NLP enables humans to derive meaning, enables computers to derive meaning from human or natural language input. And this is not something new. This field has been around for over 50 years. One of the classic examples of NLP happened in 1966. This was the ELIZA chatbot. It was developed by a psychotherapist named Joseph Weizenbaum. And it was done in a clinical setting to try to give some feedback and back and forth to patients who were either close to dead or on their deathbeds. So for example, it would be very kind of naive parsing and keyword replacement. It would do something like, if the patient would say, "My head hurts," the chatbot would respond, "Why do you say your head hurts?" So it would just be this very kind of naive way to interact with the patient. Although it was naive, it did manage to pass the Turing test to some extent, or part of this kind of complicated Turing test where you have a human and a computer behind a closed wall and you're trying to figure out or trying to guess whether or not that is actually artificial or not. In 50 years, the progress has been made, though. Much progress has been made. And I want to give an example of just recently, Microsoft's released Tay&You, an AI chatbot on Twitter. And this is interesting. It was kind of a neural network that learned dynamically how to tweet based on people tweeting at it, right? So every tweet that it received, it learned from that tweet and tried to spit back a tweet in response. It sounded like a good idea at the time, but it ended up to be semi-disastrous because Twitter is a sewer, as it were, of content. So the bot ended up being this race-baiting, fear-mongering, sexually explicit, terrible Nazi bot. And so they suffered some PR disaster from this. Anyway, I'd like to make the point that InfoSec in machine learning has traditionally emphasized defense, right? The adversary or the bad actor comes and tries to penetrate some system or some network. And it's the job of the vendors downstairs in the booths and the products to try to provide defense or try to remediate these offensive attacks. So it's very reactive in a sense. And you can see this throughout the last 10 or 15 years at Black Hat. There's been a slew of amazing talks how to do spam filtering in email, talks ranging from botnet identification to network defense to intrusion detection. And we think that we can take lessons from these defensive things and apply it in an offensive manner. So data is not only useful to the defensive InfoSec worker, but also on the offensive side, right? So with that, we want to talk today about Snapper. It's an acronym for the Social Network Automated Phishing with Reconnaissance tool. The tool is split up into two phases. In the first phase, it takes as input a list of Twitter users, and we'll go more into this later. But it extracts a subset of these users based on how it defines high-value users. So it prioritizes those users to be targeted. In the second phase of this pipeline, it takes the individual posts from each of these users' timelines and crafts a tweet at these users, prepended with their @mention username and ending with a shortened link. And we collect metrics on how often this link is clicked across many different users. And we're going to go into more details now, but I want to mention we're going to do a live demo. And demo, God's willing, it hopefully goes well, but we want you guys in the audience to tweet to this hashtag if you want to volunteer to be spearphished. We're not going to actually send you malicious content in the spearphishing message. But if you tweet to it, we're going to extract some information from your timeline and craft a tweet at you based on the interests of your timeline, and you can weigh whether or not it is something that you might end up clicking later on or not. So the trajectory of the talk is going to be, John's going to talk about machine learning and offense, and we're going to go into each of these different phases of the tool, target discovery and social spear phishing. We're going to go into detail about how to generate these tweets, and then we're going to wrap up with some evaluation results and comparing to other similar techniques in the literature.
All right, cool. So one of the first questions is, why is social media and Twitter specifically a good venue for doing spear phishing, and especially autonomously? So there's actually quite a few reasons why social networks are different than the standard emails or things like that you might think of. The first being, there's a very, very good API for scraping data off of Twitter. So anything you post on Twitter, people can collect all of the hashtags you use, all the posts, all the statuses, what time they happen, those sorts of things, very, very easily. And this is actually generalized across most of the social networks out there. There's also a very, very colloquial syntax on Twitter. I don't know if you've noticed. Perfect grammar isn't really the norm. And so machine learning models that are imperfect can still actually act on par with normal users, which is actually pretty cool. There's also this idea, like Twitter in specific has this character limit. So every single link on Twitter is shortened. And this extends to other social networks too. Most links on these social networks are shortened. And so it helps with obfuscating payloads. So if you want to send something to someone and don't want them to know where the link goes to, it's very easy to do. Next, there's this sort of trusting culture, right? Email, everybody knows what the Prince of Nigeria is, I hope. Nobody's going to respond to that. But nobody really suspects, social networks as harboring malicious, intent, right? If somebody tweets at me saying, hey, check out this link, I'm going to be like, cool, and I'm going to assume it's, associated with my interests. And that's actually one of the things that we're trying to bring attention to today and with releasing this tool. And finally, there's this idea of incentivized data disclosure, right? So basically, when you get on Twitter or Reddit or whatever, you want people to like and share your posts. You want to get upvotes, karma, whatever. And that's actually something that's really interesting because it makes people want to share personal details about themselves, right? And so it ends up being like a prime venue for testing out these sorts of things. And before we really get into it, there was a really cool talk at ShmooCon called Honeyfish, and we just wanted to give a really quick shout out to them because they were a huge inspiration for this project. But getting into the nitty gritty of what Snapper does, first off, as Phil was saying earlier, it prepends tweets with an @mention, right? And so for Twitter in particular, if you have a tweet with an @ at the beginning of it, it actually treats the tweet differently than all other tweets. It calls it a reply. And so that means only followers who follow both you and the person mentioned in the @ can see the tweet. And since we're making our own bots here, if we don't have any followers, that means only the target can see the tweet. And so we know if the link that was clicked was, if we know the link was clicked, we know it was that target who clicked the link, which is actually kind of cool. And on that same vein, our tool in the box shortens the payload uniquely for each user. So that means that we can check and say, hey, this particular target, we sent this particular link, and they clicked it or they did not click it. And that actually ends up being a pretty huge strength. As Phil was also saying earlier, we triage users with respect to value and engagement. So one thing is if you just get on Twitter and start spamming links over and over again, generally you'll get banned. The thing here is we actually save API requests and sort of hide a little bit better if we only target people who are likely to click on the links, right? And so we have a machine learning model built in to where it actively triages these users into those and only targets those users. And then finally, in the box, our tool obeys rate limits. Now, of course, bad people can get around these, right? But this, makes sure that Twitter doesn't, get upset or anything like that. A few things that aren't in the box that you probably want to do if you use this tool. If you only post links, Twitter's actually pretty good at finding that and banning you. So you have to mix in some normal content in as well. So some non-phishing posts, some links, some posts without links in them, some posts without particular @ mentions. And another thing is you have to build a believable profile, otherwise no one's going to click your links as well. If you just have standard first thing you create is an egg profile, if you just have that, nobody's going to click on you. So those are two things that don't actually get wrapped up into our box, but you need to add as well. So at a very, very high level, how the tool works, first it goes through, you give it a list of Twitter users and a payload, and it calls basically for each user, it calls a machine learning model to find out if they're a target. And assuming they are, then it goes and collects their timeline to a specified depth and generates a tweet, either using a Markov model or a neural network. After you get the tweet, you can also say whether or not you want it to schedule the tweet for some time that the user is very active, or you can just go ahead and post the tweet in case you're doing something like a live demo on stage. And with that.
Cool. So with that, we'll go into the first phase of this tool, automated target discovery. So we're going to use clustering to try to prioritize targets out of a given list of input users. So first of all, here's an example of a Twitter profile for those of you who aren't familiar with it. As John mentioned before, you have a ton of accessible personal information listed there. Not only in the description part of the profile up in the left corner below the name of this is Eric Schmidt, the former CEO of Google. But you also have a ton of personal information listed in the tweet history of this person, historical profile posts, and you have not only text-based information, but you have heterogeneous information like integers like the number of followers and the number of following. You have dates like when the account was created. And you have a ton of different kind of Boolean or binary yes or no fields in the tweet indicating whether or not they've changed their default profile settings from when they first started when they first signed up for Twitter. So this is what that profile looks like when you make a Twitter API call. So you get a JSON formatted response like this. And we use this information at scale to extract features and to cluster these users or group them together according to these features. So the first thing we look at is the content of the description and why that may be useful. For example, for Eric Schmidt, if you list something like a job title, like you're a CEO, CTO, CISO, CSTARO, or a recruiter, somebody that might have access on your network to some more sensitive information, this is usually the tool selects this as a solid indicator that that person should be prioritized in the target list. Next is the level of engagement. The tool tries to select people or users who have a high engagement in Twitter, so they have a lot of followers or people following them. The account age or hashtag #myfirsttweet, how long has the account been active for? It's just measuring, again, kind of engagement, how active is the user on the network. And it measures some of these default settings, like has the profile background image, or is the image, is it still an egg profile? Have those fields ever changed, or are they still what they were when you first created the account? So to give an example here, again with Eric Schmidt, if you can take all those different kind of all those different features and all those kind of fields from the raw Twitter API call and featurize them and project that into a 2D map here. You have one Twitter user expressed as a point on this 2D plane. And so one Twitter user, Eric Schmidt, expressed on a plane of many, many other Twitter users. So this is kind of how we apply clustering. You can imagine that Eric Schmidt might belong to the cluster of users that we want to target, right? So the users that belong to the red target are the ones that we select as targets, and the ones who belong to the green or the blue ones we kind of push aside. And this is optional in the tool. You can choose to do this or not depending on how much you want to scale this kind of activity up. So clustering kind of below the surface here, you have many different kinds of clustering algorithms that you can use to do this, and each of those algorithms have a certain number of associated hyperparameters, so parameters associated with each of those clustering algorithms like k-means, dbScan, et cetera. How we end up selecting the true model that we end up deploying, we choose it based on the maximum average silhouette score. So the silhouette score is a measurement that's bounded between -1 and 1, and it shows how similar a data point is to its own cluster versus how different it is compared to data points in other clusters. So it's like this measurement of cohesion versus separation between the clusters. And we found that for the model that we ended up selecting, we have a silhouette score of around 0.65, and so this is in the literature thought of as kind of a reasonable structure to select from. And so in this plot here, you have different algorithms and different number of clusters. This is the parameter we're tuning here, 1, 2, or 3. And they're labeled starting at, they're 0 based. And so each data point has a silhouette score associated with it. And so the way that we select it is this average. So the dotted red line averages across all of these different silhouette scores, and that's the average silhouette score. And that's basically the line that's furthest to the right in this plot. That's the algorithm and the hyperparameter that we're going to select. Right.
All right, so before we get into actually generating the text, let's talk about maybe some of the boilerplate around the tweets. The first problem we ran into is we want to choose like a URL shortener to, hide a payload or something like that, right? And we found this malicious link. It's malicious and phishing. Several records on VirusTotal say it is. We checked it out. It is. And we looked through a lot of different URL shorteners, and we found goo.gl lets us shorten it, and several others. And as a side note, it looks like actually this is being used, in the wild or pen testing or something, because it's when we actually shortened it was at the far right, and people are clicking on this shortened link well before we actually we shortened it ourselves, right? But another thing is like we went through, and goo.gl also gives us analytics, which is really, really cool. It tells us, what referrers actually clicked on the link, what countries they're from, the different browsers, for example, like, Chrome, Safari, whatever, and even the platforms. So like we can tell if somebody clicked on using an iPhone versus Android versus, some like Windows or something like that. So these are all desirable properties of a URL shortener, right? For example, another thing is goo.gl looks legitimate, right? People, see a goo.gl link on their timeline, they're not going to be, oh, hey, that looks a little fishy, right? It's from Google, it's probably safe, right? But we just demonstrated that goo.gl can link to malicious sites. So that's definitely something that we want in our tool, right? Again, it also gives us really cool analytics, but it has a lot of APIs that we can use to both obtain these analytics programmatically and create shortened, unique payloads on the fly. So this is why we actually ended up choosing goo.gl. But note, like we definitely want to emphasize, we never actually posted malicious links on anyone's profile. We only used things like google.com as our, spear phishing payloads in our tests. So please don't get mad at us for that. Another thing that we do some minor recon and profiling, recon and footprinting for profiling. So two major things that we do. First, we want to figure out a good time to actually post the tweet, right? And so if we, are running our tool at 12 in the morning and the user is in a different time zone and it's 7 o'clock, at night and they're not online or whatever, we don't want to post the tweet then because it's not likely that they'll see it, right? So through Twitter's API, what we do is we grab all of their recent tweets and we generate, a histogram of what their, tweet time frequencies are, right? And so this is actually my my own personal profile on the left. So apparently I like to post a lot at 11 p.m. Take that what you will. But so we can actually schedule the post, and we do so by selecting a random minute within the most frequent hour that they actually post themselves. Another thing that we do is we look at the topics that they like to post about. And actually, first we were doing some really complicated, topic modeling type stuff. But then we found actually just a simple bag of words on their timeline tweets works really freaking well. So we use that and we just seed the model with a random topic that the user frequently posts about.
Cool. So to proceed here, now we want to get at the nitty-gritty aspect of this tool, how to generate a tailored tweet towards a specific user. So again, to reiterate, we've gone through and we've selected a subset of users, and we've calculated when they like to post a tweet and what they like to talk about. Now we want to generate a tweet towards them. So to do this, we leverage two separate different architectures. One is a Markov model, and this has been popular in terms of text generation for a subreddit simulator, InfoSec TitleBot. The idea is basically that given a corpus, and a corpus here is defined as a history of tweets, maybe the last 200 tweets, last 500 tweets, last 1,000 tweets, however much data you want to grab, reads through those tweets and calculates pairwise frequencies between the words that are contained within those tweets. Right? So for example, here you have the word I and you have the word don't, and that might in the corpus give you a 0.38 probability of transition. And you also have the word like, and you have kind of this normalization here, so you have a 0.62 of transitioning there. So then when you go back to then generate a tweet based on this history, it's going to look like Twitterese or something that one might expect from someone posting in English, and it's going to resemble kind of the topics that they've liked to talk about historically. Again, this is like a state-based Markov model, and it's based on transition probabilities. We tested out a different model, which is a bit different, and this is a LSTM recurrent neural network. LSTM stands for long short-term memory. This is a bit more cumbersome. We had to use an Amazon EC2 instance, and we had to go out and grab 2 million tweets to pre-train the model with. To grab these tweets, we didn't go out and just randomly sample from Twitter, because like I said, Twitter is a sewer, so you're going to get a lot of weird stuff, right? So Twitter actually has an account called @verified, and this is basically all of the officially verified Twitter accounts, or it follows all of the officially verified Twitter accounts currently on that platform. And so the idea being that if your account is verified, you're likely not some automated bot or some kind of weirdo. You actually might have like some public image, or you've been pre-selected by Twitter to be like a representative user. So it took 5.5 days to train this. And we used 3 layers of this neural network, and we had about 500 units per layer. And the idea of the LSTM as opposed to the Markov model, like I said, the Markov model only computes transition probabilities on a word-by-word basis. So it only looks at the word that the current word is adjacent to. What the LSTM model is much better at is it gets around this problem of long-term dependencies between words inside a tweet, right? So you might have a word that occurs later on in a sentence that is somehow related to a word that occurs at the beginning of the sentence. It provides context for it. Recurrent neural networks like LSTM are really, really good at solving this problem because they have this gated type architecture, which allows information to be saved off or kind of passed on a dynamic basis. There are some trade-offs and caveats to these two approaches. First off, the training speed for the LSTM, as I mentioned, takes a while. It takes a few days, and it takes a decent amount of computing architecture. For the Markov chain, supposedly it only takes a matter of milliseconds. You can dynamically take the Markov chain, point it at someone's last 1,000 tweets, and there you have kind of like a naive model of what they like to talk about. We didn't see much difference. We didn't see a significant difference in the accuracy between these. And accuracy, by that I mean the click-through rates. So we scaled this up and targeted a lot of users and then measured how often a user clicked through to the appended link versus when they didn't. The availability of both of these different tools are public. There's public tools both to train up an LSTM and a Markov model. And the relative size of these on disk, the LSTM is much bigger. The advantage of the LSTM generally is you get kind of a deeper representation of what it means to be posting on Twitter, like a Twitterese, like we like to call it. It's not quite English or it's not quite whatever language have you. It's kind of this abbreviated syntax laden, different punctuation, emojis, URLs, everything you want thrown in there, broken language. And so we seed the neural network with the topic that John talked about before, and it generates something that looks fairly legible. Then for the Markov chain, what you can end up having, because you look at only a subset of the tweets from their history, you can end up overfitting to that user somehow. And by that I mean, if someone is talking about temporally relevant information, on one hand, like the Olympics in July or August, and then you go ahead and point this model at them in October or November, that might be kind of an event that happened in the past and no longer relevant, and that might raise suspicion that you're being targeted by a bot, as it were. Right. So one of the cool things, though, we like to point out about Markov models is that because they're based on the content of each individual user, it's kind of more dynamically deployed. You can actually, out of the box, get a tool that is language agnostic. Right? So you don't have to be having your tweets in English. It can be in Spanish. It can be in different character sets like Russian, Chinese, or Arabic even. Like I said, the Markov chain just simply calculates transition probabilities between these words. So you can generate, so I've been told, fairly legible tweets in different languages using this tool. And for the neural net, oppositely, you would have to go out like I did and grab tweets from verified users in English mostly, and do that same kind of process if you want to target different languages in advance. And kind of the take-home point here, we don't want to necessarily harp on the fact that Twitter is susceptible to this. This approach can be applied on any social network, and we would argue even more broadly, any kind of online communication service where people are interacting with each other. It raises this issue, of like, how do you know you're talking to a bot or if you're not? And with that, I'll pass it on to.
Yeah, cool. Awesome. So before I start the evaluation results and demo section, I just want to remind you guys we are releasing the tool. It's on the Black Hat CD, DEF CON CD, and we'll have a GitHub repo up shortly. But you can verify all of this yourself. So we started off with some wild testing of Snapper, and it actually did surprisingly well, right? So the bottom is some of the tweets that it was generated, and you can see it's talking about we started scraping, hashtag InfoSec, hashtag Pokemon Go, things like that. And you can actually see things like it's talking about Woody Allen, and seventh tweet down is talking about Pokemon Go and things like that. So it's actually generating some pretty good tweets. And even when we posted some of them, people were, responded saying, thanks, but link's broken, right? So this is very good proof of concept, right? So we did a pilot experiment. We basically used Snapper. We pushed a button saying Snapper Go on 90 different people using hashtag cat, because cats are cool on the internet and whatnot. And we were actually really, really surprised. Even in this first prototypical pilot experiment, after 2 hours, we had a 17% click-through rate. And if we let the link saturate a bit, after 2 days, we had a 30% to 66% click-through rate. And the reason for this sort of huge range is because actually there are a lot of bots that crawl through Twitter and click links randomly. So that was really interesting to me. If we use the actual like strictest definition of what a user might be, so making sure like the refer is actually t.co and making sure like the location matches up with their profile and things like that, we get a 30% click-through rate for that pilot experiment. If we use a little bit less strict requirements for verifying whether someone's clicking a link as a person versus a bot, like for example, not making sure the location matches up, we actually got a 66% click-through rate there. We're trying to avoid being fuddy, so we're giving the 30% as like our actual rate of success here. So then later we were actually trying to sort of stress test the tool and see whether or not the tool itself was actually better than a human at phishing people, right? And so we actually had a bake-off. We had a person generate phishing tweets. And the strategy he used was he copied and pasted messages to different hashtags. He was able to, in 2 hours, target 129 people, which comes out to 1.075 tweets per minute. And he got 49 click-throughs. With one instance of Snapper, we were able to target in that same 2 hours 819 people, which comes out to around 6.85 tweets per minute. And we got a total of 275 click-throughs. And furthermore, with Snapper, you can actually arbitrarily scale it to the number of machines you have. So the fact that just one instance was able to outperform them is actually pretty freaking cool. So as sort of a summary, and with some actual stats, phishing, generally speaking, is already mostly automated, right? You can click a button just like our tool, and you get really, really low success rates. So you get between 5 and 14% accuracy is what we've seen the best phishing campaigns have. On the other hand, spear phishing, which is highly manual, takes around like 10 minutes to actually create a single post because you have to research the target, figure out what they like, figure out what time, that sort of thing. It's super highly manual, and you only still get around 40 to 45% accuracy in the best spear phishing campaigns. And in our multiple tests, we found that Snapper actually is fully automated. We just click a button and it runs, and it gets between 30 and 35% of people clicking through the link, which is actually pretty high. And so with that, we'll actually go ahead and pray to the demo gods and hope that it actually works. Cool. Just see, okay, so we got about 51 people who tweeted out the hashtag. All right, so this is actually the command to use it. And of course, I'm not in my virtual environment. Yeah. Cool, so what this is going is it's actually going down and retrieving the person's timeline and creating, this is the actual tweet, this is my actual personal account here, right? Because we want to make sure we have something that works. And so Twitter's API sample for the most recent scan, and here's the unique Google link for me. And so we can actually go over, here's our little bot guy who's tweeting. And hopefully, yeah, there we go. So it automatically tweeted to me, that actual post. And notice first off that it's not going to show up on my tweets or tweets and replies. Where it's actually going to show up is in my notifications because it's a reply like we talked about earlier. And here it is. So like I'm the only person who can actually see this tweet. And I can blow that up a bit. But yeah. So it goes through, that was completely autonomous, right? I was standing here making a talk, not writing a post. And it's actually scrolling through you guys and sending you guys different posts. And here's some of the ones it's generated so far. So yeah, pretty cool.
Oops, yeah. going to go away.
Oh yeah, sorry about that.
Let's do that. Yeah, so then just a few slides to wrap up. So why did we do this? We did this for awareness and education. We want to make sure that people are aware of the danger or the susceptibility of Twitter and social media in general to phishing attacks and spear phishing attacks. Like John said before, we think that email is a methodology that people are more in tune to. They get training. It's kind of a well adapted system there. But in terms of social media, people are a lot more flamboyant and careless, we think, when it comes to clicking on links. You could also use this tool to automate internal pen testing. You can imagine if you have all the Twitter usernames of your company or your organization or whatever it may be, run this tool on that subset of people, you can gather statistics on how likely those people are to be targeted and actually follow through and click through these links. You might also use this for kind of non-InfoSec related things like advertising or staff recruiting. It allows you to go out and gather data and tailor messages towards people. This might be very useful in those contexts. Again, emphasizing we're white hats here. Machine learning, though, is something that we think you're not going to have a PhD soon in order to be able to talk about it or do this kind of thing. It's going to become a lot more layman, and it's going to be spread a lot more and become a lot more normal in people's products and the way that people talk about these kind of solutions. So we just want to raise awareness about this issue and that it can be used offensively in general. A way to get around this is to protect your account. So you can go that, you can change your Twitter notifications, and this will make it impossible for someone to automate scraping of your timeline. Another mitigation might be that bots can be detected. There's been some defensive machine learning talks already at Black Hat this year and in the past. Bot detection is kind of a well-known technique, especially on Twitter. People have written machine learning models like classifiers that can tell whether or not, based on certain features like how often or how regularly accounts are posting, and use these to determine if that account is a bot or not. And again, standard mitigations apply. So if you think that you're being targeted, report the post, report the tweeter. Twitter is usually pretty good about following up on this and at flagging spam accounts. So to summarize here, ML can be used offensively to automate spear phishing, and Twitter is a good venue to use this because their users, they have a low bar of permissibility for acceptable messages. You don't have to create the most convincing or compelling tweet to target somebody because of broken syntax, abbreviations, and stuff like this. And finally, social media is unique in that abundant personal data is available, and this can be effectively used to socially engineer somebody. And with that, we'll take some questions. I think we have 5 minutes. And if you guys want to talk to us afterwards, we'll be at the ZeroFox booth at number 1 or 1032 after the talk. And we are going to release the source code. If you have the Black Hat disk already, it should be on there. But we're going to publish the GitHub link on our Twitter profile. So look out for that. And thank you. Yeah, cool.
Awesome.
So if you have a question, maybe just step up to a mic. Cool.
Hi, thanks guys. I have a question. So does this also work for direct messages for DMs, or is it only public tweets?
So our tool only does public tweets right now. We figured it would be a little easier just to implement and things like that, but we don't see any reason why it wouldn't work for DMs as well.
And Philip, when you mentioned the protected tweets, did you mean the completely locked down, only followers can see it, or did you mean something else?
Yes, exactly. So you can go to your Twitter settings and change your account from kind of a more public setting, which comes as a default, to like a protected setting, and that will make it impossible for someone to go out and use the Twitter API to scrape data off of your timeline.
So yeah, like there are some bad sides with that. Like you actually have to accept followers and things like that. But we'll also emphasize you should treat social media like you would treat email. Actually, like look at the link, make sure that the person that tweeted it to you is someone you trust, et cetera, et cetera. But if you're, the really paranoid type thing, this is an easy way to completely defeat this tool.
I saw that there was emojis used in some of the tweets, and I was just wondering how the tweets that you all sent back to somebody, how does it just treat it as a character, or how does it assimilate that into the tweets?
Right. So this depends on how you pre-process the tweets. So, you can treat each word, you can separate on white space, for example, or you can pre-process away things. Like, for example, we pre-processed away and we eliminated specific usernames and specific URLs because we thought that it'd be weird to be posting URLs maybe that are built by a neural network, so they might be completely random or nonsensical. Right. Same thing with a username. You might get an @mention looking something like a real Twitter username, but probably not likely, right? Yeah. But in the case of in the case of emojis, like you said, this is something that can be learned and then generated on the fly.
Markov text kind of tend toward getting stuck in loops in my experience. Do you just trust on the character limit to prevent that from happening to you, or do you detect that at all?
So actually, for the Markov, we use word-based first off. So and because of Twitter's short character limits, we haven't actually seen it getting stuck in loops very often. If it does, we just chalk it up to, it was a bad tweet, it's not going to get clicked, right? No machine learning system's perfect. But it still works well even with those sorts of downsides.
It's definitely a valid criticism, yeah. And if it gets stuck in a loop, like you said, it's only 140 characters, so if someone repeats a word over and over again, they just might feel really strongly about that word.
Okay. Cool, any other questions? Awesome, thank you guys for, we get one more.
Yep, thanks.
All right, cool, thank you guys for coming.